Hey guys, my name is Sandeep Patel. In this video, we are going to solve another problem based on the recursion, right? So in this problem, we are given an array and then we have to find how many times the target element appears in this array. For example, so there's an array here. It says 1, 2, 2, 2, 3. So there are 3 times 2 appears, right? So we can say, okay, if we're finding target 2 in this array, there are 3 times, right? So that's basically the problem, and we're going to solve this problem using the recursion technique that we learned, right? If you haven't watched my video on the recursion concept, I would suggest you do that first, because it will give you a detailed explanation on how to solve problems using recursion, right? Alright, so in the recursion approach, we basically take two-step approach, right? The step one is breaking the problem into a subproblem, right? And then step number 2 is solving that subproblem, right? Um, so in order to find a number of occurrences, right? First, let's break down the problem, right? So how are we going to break the problem? So let's take an example of this array here, right? So let's say that I call this count occurrence function with this initial array, right? Now, I want to break this problem into subproblems, right? So basically what I would do is each time I can call the same function by removing one element at a time, right? Um, so first time it removes 1 from the array, second time it removes 2 from the array, third time it also removes 2, and this problem is becoming smaller and smaller, right? So next time you will have only 3 left, and finally you will have no element left, right? So that is the base case, right? So base case is when there are no element left inside the array, right? So basically we had this big problem that we break down, and we broke the array in such a way so that it become really small, and we can tackle the small problem first, right? So that's the second step, right? So can we say that when the array has no elements, right, there are 0 occurrences, right? Can we say that, right? So that will solve this problem, right? When array is empty, then we cannot find the target element and it should return 0, right? So let's take that step first, right? So step number 2 is solving subproblem, right? So we're gonna solve the smallest subproblem first, right? In this case we will say when array length less than equals 0, then we will return there are 0 occurrences, right? Now how do we break the problem, right? So basically we can call the same function like this, right? And what we do here is that we will pass our original target, right? And then original array, and then we will slice one element from this array, right? So this code basically call itself by removing one element from the array, and the first, which is removing the first element from the array, right? Each time it call itself, right? And this function will run until we hit the base case, which is when array length is 0, it returns 0, right? So at this point we solve only one problem, the subproblem, right? But we still haven't addressed the issue where we have to count the occurrences, right? So how do we do that? Okay, so each time when we slice the first element from the array, can we compare that with the target, right? For example, in this example, this is initial call, and the first call, when we slice off 1, right, from the array, can we compare it with the target? Let's say we compare it with in this case when we call this array, we're trying to find 2, right? So can we say 1 double equals 2, right? So this is false, right? In the second time it comes at 2 triple equals 2, right? This is also triple equals. So when we met our condition, we need to increase the count by 1, right? The count increases by 1, right? So how do we do that, right? So basically we can call the same function if array first element triple equals target, then basically we have to call the same function. However, this time we have to add 1 in the beginning, right? So when we do 1 plus, that means we found the target and we're just adding 1 count to this occurrence, right? So let's check this and see if this works. Okay, so when we run this code, you can see it's working, right? For empty array, it returns 0. When array is 1, 2, 3, and we try to find 2, it's occurring only one time. That's why it's returning 1. When array has multiple elements, in this array there are 3 2's. That's why it's returning 3 as an answer. Okay, so now the time to calculate the time and space complexity, right? So for time complexity, what we're going to check is how many time a statement is called within this function. For example, so there are like 1, 2, and 3 statements, right? So for each statement, we're going to see how many times this statement is called when function is called. So when the count occurrence function call, this will be called 1 time. So this is O of 1. This will call itself. Let's say in most cases it will call n time, right? If there are n occurrences, let's say this array is filled up with 2's, right? In that case, it's gonna call itself n times, n meaning that the array length, right? And similarly here, right? If there are no elements, this will be called like O of n time, right? This function will call itself n time, right? So that is the overall complexity of time complexity in this problem, right? How about the space complexity? So for space complexity, we are not using any additional variables. However, we are calling the function using recursion, right? And recursion creates a call stack in the memory, right? And so if there are n calls, that means there are n calls in the memory stack, right? So we have to count that memory, and that's the reason why this call stack takes this O of n space as well, right? I hope you like this video. Please do like, comment, and subscribe, and wait for my another video on recursion. Thank you.